Hello, and today we'll be going over the periodic table, the characteristics of the groups of elements. You guys might be wondering, why does this matter to me? Well, for starters, the periodic table is super important to basic chemistry. However, when one knows each of the groups in this table, they're unlocking a lot of information about multiple concepts such as solving chemical equations or naming compounds. It's really not so hard to memorize these groups because they all share some basic parts. Each group is sort of like a family. Each group is a family, and each family is different from one another. When you know the quirks of each of these families, you will immediately know which elements will interact with ones from a different family. First, the alkali metals. The alkali metals are the group right here. They have a charge of +1 and are exceedingly reactive. Alkali metals are malleable, which means they're able to be hammered into different shapes without breaking, and they're good conductors. Here are some examples of these that you can probably relate to better than me rambling on about various names on a table. Sodium is our common table salt, and potassium can be found in a nice yellow banana. Now, the alkaline earth metals. This is the group right here. The alkaline earth metals and the alkali metals are a lot alike in that they're very reactive. However, alkaline earth metals are slightly less reactive, have a charge of +2, and they have 2 electrons in their outer shell. Some examples of these in our world are magnesium, which is found in chlorophyll, and strontium, which is found in fireworks. Now, the transition metals. This is the largest group in the periodic table. And they're right here in the middle of this yellow group. The transition metals have various charges for different elements throughout their group. They are mostly unreactive, they're good conductors, and they have high boiling and melting points. Here are some examples of these elements. There is titanium, used for aerospace crafts, and iron, which is used for bridges, such as the Golden Gate Bridge shown here. The other metals. The other metals are malleable, have a relatively high density, and are opaque. Let me circle these guys for you so you can see them. They're right here. These elements have different charges and are between the transition metals and the metalloids. Some examples of these are tin, which is used in some instances to make pens, and aluminum, which is used for making golf clubs. The metalloids. These are the metalloids, this green group, right here. The elements in this group have charges that vary. Metalloids have characteristics of both metals and nonmetals, and that some of the elements in their group are semiconductors, or conductors in certain circumstances, kind of like the metals, and some are brittle, which is a lot like the nonmetals. Some examples of these in our world are silver, such as this beautiful ring shown here, and there is also the example of lead, used for weights and weightlifting. Now the nonmetals. The elements in the group nonmetals have various charges. They're right here. Don't forget hydrogen hiding over here with the alkali metals. They gain electrons easily. They're brittle solids and are poor conductors. Some nonmetals in our world are phosphorus, found in our bones, and hydrogen, found in the stars that you see in the night sky. The halogens. This group is wedged between the noble gases and the nonmetals. Halogens are right here, this magenta group. The halogens have 7 valence electrons that are highly reactive with the alkali metals and the alkaline earth metals. Some examples of these are fluorine, which is in the toothpaste that you use every morning and night when brushing your teeth, and chlorine, which is used to clean pools that you swim in during the summer. The noble gases. Noble gases are these elements on the right. this blue group that I was talking about a minute ago. Noble gases all have a charge of 0. Noble gases are almost completely unreactive and are able to conduct electricity as well as are odorless as well as colorless. No stinky gases for you today. Some noble gases in our world are neon, which is found in some lights, and krypton, which is in the flashlights. And no, it has nothing to do with Superman's home planet, fellow comic book nerds. Now, the lanthanides. All the elements in this group have a charge of +3, and these guys are right here. They're often forgotten because they're shoved down here at the bottom of the table, away from all the other ones. The lanthanides have high melting and boiling points. This group is also very reactive. Examples of the lanthanides in our world are europium, which is used so we can see color on our TVs, and thulium, which is used for laser surgery to help people's eyes. The actinides. The actinides are a radioactive group. They're very dense metals, and the elements in this group have varying charges. They're right below the lanthanides. Right here. They're capable of combining directly with most nonmetals as well. Some actinides in our world are plutonium, which is found in nuclear bombs, and actinium, which is found in a radioactive medications. Today we went over the 10 groups of elements in this periodic table and what sets them apart from one another. This is Megan Flowers, and I hope you enjoyed this video. Thank you for watching.